All right, guys, here we go. So we're back at it again. So we're on. Don't worry about the dates here. These dates are from my notes. So it's today, the 17th of April. So these should follow your notes for. Excuse me. This should be Monday, and that should be April 17th. So Monday, April 17th, we're going into binomial distributions. Those of you that are in class today kind of heard me talk about it. Those of you who weren't, uh, this is one of the hardest parts. These binomial distributions are one of the hardest things that we tackle. Normally, they're the most missed questions on the AP Stats test. There we go. Change colors. So when we have a binomial setting, we have what's called our conditions. It's kind of like the normal conditions, but it's bins. And since we're talking about success and failures, you can think of it as the idea that we have a bin of stuff and we're drawing out of a bin or a hat. Okay. So to draw out of a bin or a hat, you have to have these conditions. Binary means that you have two choices. This should say success or failure. That may kind of clarify for some people in class. Maybe that's why they were asking me that question. This is supposed to be or failure. So it's success or a failure. You only have two choices. You like a make or a miss, or roll a six or don't roll a six. So you only get two choices. That's why it's binary. By means two. Independent. It's not the 10% rule. It is literally, it does one success influence the next success, or was one failure influence the next failure? So are they truly independent trials? N is for the number of trials, and it has to be fixed in advance. So if it's got to say 10 trials or 20 trials, it's got to say it in advance. And success, the probability of success must be the same all the time. So in other words, rolling a dice to get a six, no matter what roll it is, you get 1/6. That's your chance of rolling a six. So your successes, the probability of a success must be the same across the board. All right. So, what's a random binomial variable? It is literally your number of successes. So, uh, it's the count of X number of successes. Okay. And remember, the possible values are 0 to N. So, how many trials they are, because we're going to do stuff like 10 out of 25 or 12 out of 25. So, it's the top part of the fraction. This is where our parameter stuff comes in. Don't forget, we're dealing with N and P. So our N is our number of trials and our P is our probability of success. Okay. So we're back to N and P. This is where the N times P hat and all that stuff comes from. What are the common mistakes? Most of the time, they don't realize that they are supposed to using binomial distribution is appropriate. That's usually the biggest issue. All right, so let's tackle a few problems here. So, roll a fair dice 10 times. Let x equal the number of sixes. So we know that it's a 6 or it's not a 6. So we're good. We've satisfied that there. We know that they're independent. One roll does not affect the next. So we're good. That's a yes. Are the number of trials preset? Yep, we're going to roll it 10 times. Is the probability the same? Yes, it's 1 out of 6 every time we roll it. So the conditions are met for that one. The conditions are met with that one. Next, we have bins here. A make or a miss? Yes. That's a shot shooting a basketball. Independent? Yes. 20 trials? Yes. Probability the same? No, because at various distances on the court, the probability changes. C, observe the next 100 cars and go by color. There are so many colors, the first thing is there's not two choices right off the bat. So that's a no. All right. So here we go. We have the probability of getting a 6. Well, this is one. So the idea of the probability of getting a 6 is that it's the probability of not getting a 6. Well, the probability of not getting a 6 is 5 out of 6. So if I roll a dice once, I get 1 out of 6 probability. If I roll it again, I get 5 out of 6 probabilities. Well, if it's 4 rolls of a fair die, that means it's 1 roll, 2 roll, 3 roll, 4 roll. So what's the probability of failing? 5 to the 6 to the 4th power. So I get 0.482. That's the probability of getting 0 6s. So what's the probability of getting 1 6? The probability of getting 1 6 is a success with 3 failures on a roll. Then we could get a failure first and then a success and then 2 more failures. Or we can get 2 failures in a row, a success and a failure. Or we can get 3 failures in a row and a success. No matter what, we have 1 success, which is 1 out of 6. I got a 6 one time. And then we have 3 failures, which is 5 out of 6 to the 3rd power. So technically, it's 4 of these added together. So we just multiply that by 1 over 6. And then we do 5 over 6 to the 3rd power. So what I'd like to kind of talk to you guys about here real quick is where the formula comes up that we're going to see next. And we talked about it a little bit in class. So we have n trials is 4. The number of successes is 1. The probability is 1/6. And the 1 minus the probability is 5/6. So if you really look at this formula right here, notice how 4 minus 1 is 3. And do you notice how 1 is 1? And this would be a 1, and this would be a 1, and this would be a 1. Right? So that's kind of the way it... hold on, guys. All right. So we're going to kind of take this idea and look at it from that point of view. I'm not going to worry about this. We can talk about this if somebody wants to. And we'll go from there. Hold on, guys. Let me answer. Mr. Mayo's talking to me here. All right. So this is on the formula sheet, and this is what it looks like. So we've got x equals k. Now, k can be interchanged with little x. So it kind of looks like this sometimes. It's kind of irritating. They do big X equals little x. Now, the little x is the number of successes. Oops. The number of successes. Okay. And n is the number of trials. And P here is our probability of a success. All right. So we have this formula. So what you really have to do on this is you can use this formula. It is on the formula sheet. I believe it's on the second page. Might be on the first page. And it looks like it's on the second page, actually, right in the middle with the probability stuff. We set this formula, you put this formula in here and just label stuff. Number n equals the number of trials of shooting a basket. X is the number of successes, which is making a basket. The probability of success is 18 out of 25. So you just plug everything into this, and the calculator is pretty much going to do the rest. So if we look at it this way, we're going to do this. this is using this formula up here. So I will go, I will go up here and I will look at this. So X is the number of black spaces landed on. So the number of black spaces are 18 of 38. So there's my probability. Okay. And so X is my number of black spaces. The probability is the number of black spaces landed on. And that means out of 10 tries or 10 spins, what's the number of black spaces landed on? Well, they want 5. So it's exactly half the spin. So they want 5. The probability that half the spins, or 5 of them, will be there. Our probability is 18 out of 38. And our number of trials is 10 spins. So we've labeled everything. So we plug it into the formula. Here's my probability that half of them land. So 5 out of the 10 are going to land on there. So remember, this can be K or it can be X. Number of trials goes here. Number of successes, 5 goes here. 18 of 38 to the 5th power, number of successes. And then 20 divided by 38 of the number of failures, because then there's 20 more spaces. So you got to know that this is 1 right here. Oops. Right here is 1 minus 18 over 38, or it's 20 over 38. And then when you plug this into the calculator, you end up with 0.2427. And we end up with that probability. Don't forget, you can use this. Just use the division sign for a fraction on these. So if you do 38 divided by that, I'm just going to double check my math here. That equals that. You're going to times that by 20 divided by 38 to the 5th power, and that's going to equal that. And then you have that piece, and we're going to times it by. Why did that not come up with what I wanted? What the heck just happened? But that's how you do it. I'm going to use the calculator a different way. I did it a little bit differently. So that's how you set up the formula here. Now what you're going to do is you're going to do this same idea, but you're going to use the calculator. The calculator makes things way easier. So if you use the calculator, I forgot what page it's on, but you're going to go to second vars. So it's our distribution menu. So we're going to our normal CDF page. So if you go second vars, and you got to scroll all the way down to number 10, basically, and we're going to pick out binomial PDF. So this is number 10, which really in the calculator is 0. And we're going to pick that in, and we're going to put the number of successes in, the probability, and 5. And when you do that and hit enter, it kicks it out at you, and you get your probability. If you're going to do the same thing with greater than or equal to 8, you do the same thing, except you're going to do binomial PDF, and you're going to add your answers together, and you can type it just like this in the calculator, and it's going to kick out 0.0385. So on these, you don't have to do a lot of work. You need to let the calculator do the work for you, okay? Yes, you can use it. You must define the variables, and you must show the formula. So I'll work with you guys on this stuff here tomorrow again, but I will see you guys soon. There's your video.